Scary cosmic catastrophes that could end life on Earth. The cosmos is a vast and mysterious place, filled with wonders and dangers beyond our imagination. While we often focus on threats closer to home, such as natural disasters or pandemics, there are cosmic catastrophes that could potentially pose an existential threat to life on Earth. In this video, we will explore some of the most terrifying scenarios that could spell the end for our planet. From deadly asteroid impacts to gamma-ray bursts and supermassive black holes, these cosmic disasters have the power to reshape our world in an instant. Asteroid impact, a catastrophic threat to life on Earth. An asteroid impact represents a terrifying and realistic cosmic catastrophe that could end life on Earth. The devastating collision that led to the extinction of the dinosaurs serves as a stark reminder of the destructive power of such an event. Scientists today actively monitor near-Earth objects to detect and track potentially hazardous asteroids, significantly improving our ability to predict and mitigate the risks. The consequences of a significant asteroid impact can be catastrophic. The entry of an asteroid into the Earth's atmosphere releases an enormous amount of energy, creating a fireball and generating a shockwave that can level structures and cause widespread devastation. If the impactor is large enough, it can penetrate the Earth's surface, creating a crater and ejecting debris into the atmosphere. The resulting dust and debris can remain suspended, blocking sunlight and causing a global climate shift that disrupts the entire food chain. To prevent a catastrophic impact, scientists and space agencies are developing mitigation strategies. Improved detection and tracking techniques allow for early identification of potential impactors, providing more time for preparations and deflection strategies. Various deflection methods are being explored, including kinetic impactors, gravity tractors, and, as a last resort option, nuclear devices. International cooperation plays a crucial role in coordinating efforts, sharing information, and planning responses to potential threats. The field of planetary defense focuses on protecting our planet from asteroid impacts. Ongoing surveys, advanced detection systems, and research into mitigation strategies are part of these efforts. By investing in early detection systems, space missions, and international cooperation, we can work towards safeguarding our planet and ensuring the long-term survival of life on Earth. Solar flares and coronal mass ejections, powerful solar threats to Earth. Solar flares and coronal mass ejections are formidable cosmic phenomena originating from the Sun that pose significant threats to Earth. These powerful eruptions of energy and matter can have profound effects on our technological infrastructure, including disruptions to power grids, satellite systems, and potential harm to astronauts. While Earth's atmosphere and magnetic field provide some protection, a severe solar storm has the potential to cause widespread damage and pose challenges for our way of life. Solar flares are sudden releases of magnetic energy in the Sun's atmosphere. They result in the emission of intense bursts of radiation across the electromagnetic spectrum, including X-rays and ultraviolet radiation. Although they happen relatively frequently, most solar flares are not directly harmful to life on Earth due to the filtering and absorption of harmful radiation by the atmosphere. However, in the event of an exceptionally powerful flare, the impact on our planet could be substantial. Coronal mass ejections, on the other hand, are eruptions of plasma and magnetic fields from the Sun's outer atmosphere. These colossal expulsions can contain billions of tons of material and can reach speeds of several million miles per hour. If a CME is directed towards Earth, it can interact with our planet's magnetosphere, causing geomagnetic storms. Satellites are also vulnerable to solar storms. The increased radiation levels during a flare or CME can interfere with satellite electronics, leading to malfunctions or even permanent damage. This can disrupt communication systems, weather forecasting, navigation services, and scientific research that rely on satellite data. Astronauts on space missions, particularly those outside the protective confines of Earth's magnetic field, are exposed to increased radiation during solar storms. The higher levels of radiation pose health risks, including an increased likelihood of developing cancer. Space agencies take precautions to monitor solar activity and protect astronauts by providing shelters or delaying missions when necessary. Efforts are underway to improve our ability to predict and monitor solar activity. Advanced space-based observatories, such as the Solar Dynamics Observatory and the Solar and Heliospheric Observatory, provide crucial data on solar flares and CMEs. Ground-based observatories and networks of magnetometers also contribute to monitoring geomagnetic activity. In response to the threat posed by solar storms, governments and space agencies have established dedicated entities, such as the Space Weather Prediction Center and the International Space Weather Initiative. These organizations coordinate efforts to provide timely warnings and develop strategies for mitigating the impacts of solar activity. Gamma-ray bursts, intense cosmic events with potentially devastating consequences. Gamma-ray bursts are incredibly energetic and fleeting events in the universe that emit powerful bursts of gamma-ray radiation. These cosmic phenomena occur during massive stellar explosions, or when two neutron stars merge. While the chances of a nearby GRB are relatively low, if one were to occur within a certain proximity to Earth, it could have devastating consequences for life on our planet. GRBs emit an immense amount of energy, outshining entire galaxies for brief moments. They release radiation across the electromagnetic spectrum, with gamma rays being the most energetic form. The intensity of gamma-ray radiation poses a serious threat to life as we know it, particularly if the burst occurs close enough to Earth. One potential consequence of a nearby GRB is the depletion of our atmosphere's protective ozone layer. Gamma rays interact with molecules in the atmosphere, leading to the production of nitrogen oxides that can deplete ozone. A significant decrease in ozone levels would result in higher levels of harmful ultraviolet radiation reaching the Earth's surface. Increased UV radiation has detrimental effects on living organisms, including damage to DNA, increased risk of skin cancer, and harm to ecosystems. The ecological impact of a GRB could be severe. The increase in UV radiation levels would have cascading effects throughout the food chain, affecting plants, phytoplankton, and other primary producers. The disruption of these key organisms could lead to widespread ecological collapse, affecting both terrestrial and marine ecosystems. Another concern with GRBs is their potential to disrupt Earth's climate. The intense burst of gamma rays interacts with the atmosphere, producing secondary particles such as electrons and positrons. These particles, along with the high-energy photons from the burst, can create ionization in the atmosphere, which can trigger changes in cloud formation and atmospheric dynamics. These alterations could potentially lead to significant shifts in global weather patterns and climate. The likelihood of a GRB occurring close enough to Earth to cause catastrophic effects is relatively low. Current estimates suggest that the nearest GRB capable of posing a threat is likely to be thousands of light-years away. However, the universe is vast, and given the number of galaxies and the frequency of stellar explosions, the possibility cannot be completely dismissed. Efforts are underway to detect and study GRBs to better understand their origins, mechanisms, and potential impact on our planet. Space-based observatories, such as the Fermi Gamma-Ray Space Telescope and the SWIFT satellite, have significantly advanced our knowledge of these cosmic events. These observatories allow scientists to detect and analyze the characteristics of GRBs, providing valuable data for further research. Supernova, cosmic explosions with the potential to end life on Earth. Supernovae are powerful and catastrophic explosions that occur at the end of a massive star's life cycle. These cosmic events release an immense amount of energy, outshining entire galaxies for brief periods and producing various high-energy particles and radiation. While the chances of a supernova occurring close enough to Earth to directly end life are remote, the effects of a nearby supernova could have significant consequences for our planet. A supernova occurs when a massive star exhausts its nuclear fuel and collapses under its own gravity. The ensuing explosion sends shockwaves through the star, causing its outer layers to be violently expelled into space. There are two main types of supernova, Type I and Type U, distinguished by the presence or absence of hydrogen in their spectra. The consequences of a nearby supernova depend on the distance between the event and Earth. If a supernova were to occur within approximately 30 light-years of our planet, it could have a substantial impact. The most significant threat comes from the release of high-energy particles, such as gamma rays and cosmic rays, during the explosion. Gamma rays emitted by a supernova can be extremely damaging to life on Earth. If Earth were to experience a direct gamma-ray burst, the radiation would ionize the atmosphere, leading to the formation of nitrogen oxides and other harmful compounds. This would result in the depletion of the ozone layer, similar to the potential consequences of a nearby gamma-ray burst. The loss of the ozone layer would increase the levels of harmful ultraviolet radiation reaching the Earth's surface, endangering living organisms and ecosystems. Additionally, supernova can release cosmic rays, which are high-energy particles consisting of protons, electrons, and atomic nuclei. Cosmic rays can pose a threat to life by damaging DNA and potentially causing mutations in organisms. However, it is worth noting that cosmic rays from distant supernova have been reaching Earth for millions of years without catastrophic effects. The impact of a supernova on Earth's climate is another area of concern. The release of large amounts of energy and particles during a nearby supernova could alter atmospheric conditions and contribute to climate change. For example, an increase in cosmic rays could enhance cloud formation, potentially affecting weather patterns and climate on a global scale. Despite the potential dangers, the likelihood of a supernova occurring close enough to directly threaten life on Earth is extremely low. The most massive stars, capable of undergoing supernova explosions, are relatively rare in the galaxy. Moreover, the vast distances between stars and galaxies significantly reduce the probability of a nearby supernova. Scientific efforts are focused on detecting and studying supernova to better understand their properties, evolution, and potential impacts. Ground-based and space-based observatories, such as the Hubble Space Telescope and the upcoming James Webb Space Telescope, provide valuable data on supernova and contribute to our understanding of these cosmic events. Galactic center black hole, a cosmic threat to life on Earth. The presence of a supermassive black hole at the center of our galaxy, known as the galactic center black hole, raises questions about the potential risks it poses to life on Earth. Black holes are incredibly dense regions of space-time with gravitational forces so strong that nothing, including light, can escape them. While the galactic center black hole is currently not a direct threat, understanding its properties and behavior is vital for comprehending the long-term dynamics of our galaxy. Located approximately 26,000 light-years away from Earth, the galactic center black hole, also known as Sagittarius A, has a mass of around 4 million times that of our Sun. Despite its immense gravitational pull, the black hole's current distance renders it unlikely to have any immediate impact on our planet. However, its long-term effects and interactions with nearby stars and gas clouds are subjects of ongoing scientific investigation. While these cosmic catastrophes may seem like scenes from a science fiction movie, they represent real threats that could potentially end life on Earth. While some scenarios are more likely than others, it is essential to continue studying and monitoring the cosmos to better understand these dangers and develop strategies to mitigate them. By increasing our knowledge and taking proactive measures, we can strive to protect our planet and ensure the long-term survival of our species. However, we must always remain humble in the face of the immense power and unpredictability of the cosmos, as it holds the potential to bring about terrifying cosmic catastrophes. One potential concern regarding the galactic center black hole is the possibility of a close encounter with a star. As stars orbit the black hole, gravitational interactions can occur, leading to a phenomenon known as a tidal disruption event. When a star ventures too close to the black hole, its gravitational forces can tear the star apart, releasing a tremendous amount of energy. Although such an event would be catastrophic for the star involved, the effects on Earth would likely be minimal due to the vast distances involved. Another aspect of interest is the potential for relativistic jets emanating from the galactic center black hole. Black holes can generate powerful jets of energized particles that are ejected at high speeds. If Earth were directly in the path of one of these jets, it could have significant consequences. However, the alignment required for such an event is highly improbable, and there is currently no evidence to suggest that our planet is at risk. The study of the galactic center black hole contributes to our understanding of black holes in general and their impact on galaxy evolution. By observing and analyzing the behavior of asteroids, scientists gain insights into the formation and growth of supermassive black holes, the dynamics of galactic centers, and the interplay between black holes and surrounding matter. This knowledge helps refine our understanding of the broader cosmic landscape. While the galactic center black hole does not currently pose an imminent threat to life on Earth, ongoing research and observations are essential for monitoring its behavior and potential long-term effects. Advanced telescopes and instruments, such as the Event Horizon Telescope, provide unprecedented capabilities to study black holes and their immediate surroundings, enabling scientists to gather valuable data and refine models of black hole dynamics. That's all in this video. If you like the information, please hit like and subscribe to this channel. And be connected to this channel for more space information.